Hello everyone. So I'd like to finish talking about the exercise that we started in class today about linked lists. We were working on a method that would remove a particular value from the linked list if it was there. Otherwise it wouldn't do anything. If I ask you to remove a value that's not there, it doesn't touch the list. But we saw what the strategy is, for example, if I say I want to remove the 8 in the list. So I'll start at the head and I'll keep walking until I find the 8. And when I find the 8, I look at the thing before it and I change its arrow to point to the thing after 8. So in this case, I would change 6's arrow to point to 10. And so now when I walk through, I'll go 1, 6, and I'll jump right to 10, and that goes over 8. So we say that 8 has been dereferenced. There's no longer a reference in the list where I can get to 8. Eventually, it'll be cleaned up by the Java garbage collector, actually. Okay. So that's how that works. Now, one of the things that makes this tricky in implementation is that, I asked you to go to the node before this and then change the arrow of that node. But we don't have an arrow to the node before this. Now, in the assignment, you will create arrows that go both ways. And so it'll be a little more convenient to do this, although now you have to maintain more stuff, right? If I also have an arrow that goes back from 8 to 6 and an arrow that goes back from 6 to 1, that would be a lot easier. I would just say, okay, go back to the thing before me and update this arrow. But there are more arrows to maintain there. So we're going to stick to just this singly linked list here in one direction. And we have to be a little more careful. But before we get into that, let's think about, there are actually some special cases here. So the first is the list could actually be empty, right? I could ask you to remove something, but the list is empty, so I really shouldn't do anything. If the list is empty, then the head is null, right? The head doesn't point to anything. In fact, I could empty the list. I could say public void clear just by setting the head to be null. So watch this. If I say, so this would clear the list by dereferencing everything, really. So that's saying now the head points to null, so I'll say clear the whole list. So it's actually really easy to clear a list. So just to convince you that this works, if I say list.clear at this point, this should output nothing, and it does, right? Okay, let's say I clear the list right before I add a 5 and a 0. Now the list should just have 5 and 0. Okay, so just to convince you, a clear list is where the head is null. Okay. But that's kind of cool, right? That for an array, you would actually have to delete things one by one. Okay. All right, but let's check. So if, we really shouldn't do anything if the head is null. We're not going to find it if it's empty. Okay. So let's only consider the case where the head is not null. The other thing we have to consider, though, is what if the value happens to be in the node that the head points to? So what if I want to delete the 1, for example? Well, then I have to change a special arrow. I have to change the arrow from the head, right? So now I'm saying the head should point to 6. But we've already done that, actually, right? We implemented that method, remove first. So we've already done that. That's when we say head is equal to head.next. So actually, if the head's value is the value we're looking for, we could just call that method. So we can just say the thing we're going to return is equal to remove first. Okay, so that's another special case. But in general, here's what we're going to have to do. We're going to have to keep track of two things. So now, if I've made it past these if statements into this else here, what it's saying is, okay, this thing is not empty and it wasn't in the first bin, so I have to keep going. And so what I'll maintain is two things. One is the current node that I'm on. I'll call it node. The other one is because I'm going to have to eventually change the arrow from the last thing that I saw. I'm going to also maintain a reference to the thing I saw right before. So to kick this off, what I'll say is node last equals head and node equals head.next. Okay. And so that starts us off here. So the last was what the head pointed to, and then the node is the next thing. Okay, and we'll keep looping as long as the node is not null. Okay, and to loop, what we say is, okay, so to move these over to the right, what used to be the node actually becomes the last node, and then the new node is node.next. So to say that, I say last equals node, and node equals node.next. But there's another thing. If I was looking for 8, for example, I'd be done here. So the other thing I should do is I should break out of the loop if I've found my value, right? So I say only continue to loop while node is not null and I haven't found my value. So end while node.value is not equal to the value that I'm searching for. So while not node.value equals the value that I've passed in as a parameter. Okay, so this will keep going as long as that's true. Now, once we've broken out of the loop, it could happen for one of two reasons. Number one, we actually found it. But number two, this kept moving, kept moving, kept moving, kept moving, and eventually we got to the end. So node was null. So the last bin points to nothing. And in that case, we didn't find it, actually. So there's nothing to do. We don't need to change anything. It just wasn't there. So the only time we have to change something is if the node is not null. So that means that this is the thing that must have happened. So the node was actually equal to a value. We didn't make it to the end of the list. Node was not null. So in that case, we are going to say, hey, we found it, so we're going to return it. But also, we need to update the last arrow, right? So again, if it was an 8, I would have to change 6's arrow to be node's next, which is 10. So I'll just say last.next equals node.next. Okay, and that's it, actually. And just, lower in this module, I've provided a link to this code so you can review it at this point. But let's just test it out real quick. So once you've reviewed it, let's test it. So let's say I want to remove an 8, for example. So I'll just go ahead and print out the result just to make sure that I'm actually finding it and not returning null. So I'll say system.println list.remove by value 8. Okay, so the list starts off as 168.10.50. We should now see 161.10.50. So let's see if it worked. Okay, it worked. 161.10.50. Good. And it returned the 8 that it removed. Okay. I could also say, let's just check to make sure our special cases work. So if I try to remove a 1 at the beginning, it does that. Okay, good. If I move a 0 at the end, does that. 168.10.5, the 0 is no longer there. And if I try to remove something that's not there, the list should remain unchanged and it should return null. So we see that. Okay, so this seems to be working. The only other thing I haven't tested is what if it's an empty list, just to make sure it doesn't crash or anything. Okay, so it returns null, so good. Even if the list is empty, it still behaves all right. Great, so that's all there is to removing. It's a little more complicated than some of the other things we've seen, but it's not too bad. You just have to be really careful and choose the right loop here. A while loop is really the appropriate loop to go with. So I'm actually going to have you just do a quick exercise where instead of removing by the value, I want you to go a certain number of steps and then remove whatever's there. So we'll say public, I guess we'll say item again. Yeah, so public item remove by index. So we don't, we haven't really indexed these things, but what I mean by that is just keep walking until you've reached essentially what's the index. So we'll say that the beginning here is 0 index, this is 1, this is 2, this is 3. So I want you to loop through, and so I might as well set up the loop here. I say for int I equals 0, I is less than or equal to index, I plus plus. And as soon as you get to the index, you'll do something. Okay. So, and I'll give you maybe a little more starter code than that. We'll see. All right, so go ahead and do that. And we'll have one more video after this.